This lecture video will cover chemical formulas and names for the molecular compounds or covalent compounds. Please read the OER textbook chapter section 5.6 for more detail of this. And after you finish watching this video, please start working on the homework that posted on Moodle. In the previous video, you learned how to name and write chemical formula of the ionic compound. The difference between ionic compound and molecular compound is that the ionic compound have the electron transfer between the element within the compound, right? So pretty much you learn about the name for this, and you also learn about the chemical, how to write chemical formula from this as well, from the cation and anion. So pretty much this one is going to rely on you have metal, right? And you are going to read the name of metal and followed by the non-metal. And you are going to have to change the ending of the non-metal to I, right? So that's what we kind of like, this is the general rules. There are more detail of any compound that is actually included in the previous lecture video. Please review that if you don't remember. So molecular compounds naming system would be similar as well, okay? So instead of having metal and non-metal, though, the molecular compound that we are going to look at, it would be the combination between non-metal plus non-metal. Okay, the naming system is going to be similar to ionic compound. In fact, that the first element would stay the same. Okay, however, you are going to change the second element, which is the non-metal part, the second non-metal in this case, to ending with "ide." Okay, so similar to what we have right here, right? So for example, fluorine would be fluoride. And another additional thing that we're gonna also include is we are going to include the prefixes in the name of the molecular compound as well to help us identify how many of each of those elements within the compound. Okay, so the molecular compound, the electron did not transfer, right? The electron between the two elements are sharing, so therefore there is no charges. So therefore it's necessary to actually specify how many each element within that, okay, because we are not able to use the charges on the periodic table to predict their chemical formula. In this case, we need to use the prefixes to tell us how many elements within the molecule. Okay, so the name of this is exactly what I mentioned earlier. You are going to name the non-metal first, right, the first non-metal, and then you are going to name the second non-metal. Okay, and then we are going to end this with "ide," right? Before we do all of these, you also need to specify the number as well by using the prefix, right? So that's what we're going to take a look at. Okay, so same thing for this. We're going to specify the number using the prefix. I'm going to go over more example in the next slide here, but what I would like you to look at first is that where are the location of non-metal? So non-metal would be on the left, on the right side, right? So this right corner right here. Okay, the molecular compounds can also be from the combination between metalloid and this non-metal as well. So it can be between non-metal and non-metal, or metalloid and non-metal. Okay, so the way that you are going to name these, so the first element, if the first element is, let's say like nitrogen, is going to be as nitrogen. You don't need to change it to nitrile or anything. But if you have nitrogen as a second element, that's when you need to change it to nitrile. So only the second element that changed to change their name and ending with "ide." Okay, so what do I mean by that? Okay, so we are going to take a look at how to name the binary molecular compound. So again, binary mean two, right? So two element that is in the molecule. Okay, so an example of this going to be the first non-metal element. Second one is also going to be non-metal element as well. Okay, so again, how do we know those elements? Well, it's going to be one of this that we looked at earlier, right? So these are the non-metals, and also it can be with the combination of the metalloids as well. Okay, and again, the number of each of these elements need to be specified. Okay, because we need to know how many of them within the element, right? It's not the same as ionic compound, because ionic compound composed of cation and anion. We know their charges, therefore we know how to balance them. So therefore we will be able to find out anyway how many of them in the chemical formula. But in this case, there is no such way to find out how many. So therefore we need to specify how many after we calculate from the empirical formula and to molecular chemical formula and things like that, right? So In this case, if you want to specify, you need to use the prefix. As I mentioned before, the first prefix will tell you about the number of the first element. The second prefix will tell you about the number of the second element. Okay, so these are the prefixes that will be given to you on the exam. Okay, and you are going to need to change the second element to "ide." Okay, so change the ending. So similar to what we did earlier, right? If you have fluorine, it's going to be fluoride. If you have iodine, it's going to be iodide, right? If you have oxygen, it would be oxide and things like that, right? So for example, in this case, we talked about this before, right? If it's you ending with hydrogen, it would be hydride, right? So carbon would be carbide, right? Nitride, oxide, fluoride, chloride, bromide, iodide, selenide, sulfide, phosphide, arsenide. Right, so that's what we are going to ending with. This is only applied for second element, by the way. Okay, now let's take a look at example. For example, in this case, we are going to specify the prefix of the first element, right? So this is chlorine. There are two of them. So 2 would be di. Okay, so that's going to be the prefix. Di, the first element would be named as it is, written on the periodic table. So it's going to be dichlorine. Okay, the only thing that's changing to I is going to be the second element. In this case, oxygen contains 3, right? So it would be tri, and then you're gonna ending oxygen with oxide. Okay, so let's try the next one. So the second one would be N2O. So you're gonna specify the prefix of nitrogen first. So it would be dinitrogen, and oxygen is only one, so one would be mono. So it would be monoxide, right? So pretty much if you have vowel written together, right, you can fuse them, so it would be monoxide instead of monoxide. Would be you fuse that together, so it would become monoxide. Okay, now next one, if you have the first element, if the first element contain only one atom, for example, in this case, the first element contain only one atom, this first element, these two first elements here contain 2 atoms. That's why you specify di. But whenever that you see the first element contain only one atom, you can drop the word mono. So instead of saying monocarbon, we are going to drop the word mono. We are going to just say carbon, but the second element, that's when you will need to always include the word mono. Okay, so the second element would be monoxide. So that means the mono part, the mono prefix will not be used for the first element, but mono prefix will need to be used for the second element. Okay, so keep that in mind here. All right, so let's pause the video now, and I would like you to complete these 3 for a second. Resume the video again when you finish. All right, let's check your answer to see if you already done. If you have not done yet, again, pause the video and make sure you finish this before you check your answer. So the first molecule would be diboron hexahydride, right? The second one would be phosphorus trichloride. Again, we're dropping the word mono for the first element, right? The second one would be what? Tetraphosphorus decasulfide, right? So that would be the last one. Okay. All right, so here are more practice for that. So again, my expectation for you is not only for you to be able to read the name, but you also need to be able to convert the name into the chemical formula as well. Okay, so in this case, the first one would be xenon trioxide, right? The second one would be diiodide pentaoxide. So how many, what is the chemical formula of iodide? It would be I, right? Di mean 2, so it would be I2, penta mean 5, right? Oxide mean oxygen, so you're going to have 5 oxygen. 2 iodine and 5 oxygen. Okay, so I would like you to pause the video now and then complete the rest of this. Okay, and then check your answer against mine when you finish. All right, so let's check your answer. Again, if you have not finished it yet, you will need to pause the video and complete it first. Okay, so let's take a look at C. So C, wait a second, is this going to be carbon and iodine? Or is that going to be chlorine and oxygen, right? Is that carbon, iodide, oxygen, or chlorine and oxygen? The answer is something like this. It would be chlorine and oxygen, because we are talking about binary molecular compound. Binary means 2 elements, right? So therefore, in this case, it's going to imply that these are two elements, right? Because you have chlorine and oxygen, it cannot be three, because right now we are learning binary molecular compound, which means it contains only two elements. Okay, so it has to be chlorine and oxygen, not carbon, not iodide. Okay, so it's gonna be it have to be chlorine. So this one would be chlorine monoxide. Okay, so D would be sulfur, and then 6 fluorine. E would be phosphorus, and 3 bromine, right? And then F would be dinitrogen tetraoxide. So you can fuse tetraoxide together in tetroxide as well. P2S5 would be diphosphorus pentasulfide. Yep, so let's check your answer. Now you might have a question, wait a second, we learned that noble gas do not make any compound because they already have stable electron configuration. They do not want to react with anything. How come that we have xenon oxide here? The answer is that for the noble gas that are really, really big, for example, xenon, right? So if you're looking at the periodic table, xenon is like all the way to like the bottom of the periodic table, right? So you have like helium, neon, argon, and so on, right? And then xenon is like one of very big one on the periodic table. So it tells us that xenon has a big atomic size, right? So we talked about this before. Because xenon has a big atomic size, therefore the interaction between its outer electron and the nucleus would be weak. So therefore, in this case, xenon would definitely going to be able to form bonds with another atoms at an extreme condition. For example, at high pressure and high temperature, you are able to synthesize this compound, but not with any other noble gases. Okay, because the reason for that is because the electron in xenon is actually less stable. The outer electron of xenon is less stable than the outer electron of other noble gases, because the size of xenon is actually bigger. Okay, so again, this will happen, but not in nature. Okay, so it's going to happen in the lab where you have to have it at high temperature and high pressure to synthesize this compound. So this is not a common compound. Okay, this can happen. All right, so the last thing that I would like to talk about is the naming of the molecular compound that is called acids. Okay, so the acids are the molecular compound. Okay, so this is, I'm going to specify this molecular compounds that give off hydrogen ions. This is the hydrogen ions right here. Later on in Chem 123, you're going to see more of this. This also can be called proton as well. You're going to see this later, but right now I'm just going to call it hydrogen ions. Okay, you're going to see this in 123 again. When it's dissolved in water. So that means in this case, we need to know that when we are going to name it as an acid, it needs to be in the molecular compound that is in water. Therefore, when we are talking about the acid, you are going to see the parenthesis AQ at the end. The parenthesis AQ will tell you that it's going to be an acid. Okay, so an example of an acid would be those species that give off hydrogen ions. That means that molecular compound need to contain hydrogen ions, right? So how do we know that that compound is an acid? Well, first, you will always see that hydrogen would be written first, and it's going to follow by another nonmetal. Okay, so in this case, this X right here would represent the second nonmetal, right? Because you have nonmetal and nonmetal. So that's why this is molecular compound, right? Because you have two nonmetal sharing electron. This name is going to be based off the name of the acid only when you have it written as the aqueous solution. Okay, because again, the definition of acid is that in an aqueous solution or in water, this molecule right here is going to give off the hydrogen ions, right? So which means that it's going to give off the hydrogen ions, which is also called proton as well, and another species. So pretty much that in water, this molecular compound is actually can dissociate to give a positive proton or positive hydrogen ions and negative cation or negative anion or the nonmetal ion. the second nonmetal ion. Okay, so you're gonna learn more of this later when we talk about 123. But what I want you to focus on today, okay, so the take-home message of today is that you will need to be able to recognize the acid and name it. Okay, how to recognize is the acid has the hydrogen written first, followed by the second nonmetal. Okay, and also it need to include the aqueous solution as well. Without an aqueous solution, you are going to name the compound according to what we just did earlier. Okay, so for example, without an AQ, let's say HCl like this, without an AQ, this is not an acid. Okay, so you are going to name this according to what we did earlier, which is hydrogen chloride, right? So it's going to be just that. But in this case, we are going to looking at the name of the acid. So that means we're going to looking at a little bit more in detail. Okay, so we're going to always include this. Okay, so the acid are the one that would change the pH, the change color of the indicator, right? So pretty much the amount of the available hydrogen ions in water is going to tell you about the value of the pH, which is going to be at a different value, right? Whether it's acidic or basic, like whether it's acidic or alkali, right? So you can tell by the available proton or the available hydrogen ions. Okay, so there are two types of acid that you need to know. Okay, so one is called binary acid. The name also implies as well, binary mean two, right? So this type of acid would contain only two elements. One of them have to be hydrogen, the other one would be the other nonmetals. Okay, oxy acid would be, so for example, in this case, one would be hydrogen and the other one would be anything on the periodic table, right? X can be anything on the periodic table. Oxy acid, okay, so the name also implies as well, oxy or oxygen, right? Oxy is come from oxygen, so that means this type of acid would contain oxygen, so it would be hydrogen that come with another nonmetal and also including the oxygen as well. So you might recognize some of this already, right? So whenever you have nonmetal and another nonmetal grouped together, this is what we call polyatomic ion. So that means in this case, you are going to need to be able to recognize the polyatomic ions that have hydrogen written first. So that would be the type of oxy acid. Okay, so let's take a look at the first kind. Okay, so we're going to focus on this kind first. Okay, so let's take a look at the naming of binary acid. The naming of binary acid would start with the word hydro. Okay, so the word hydro would represent the hydrogen that written before the second nonmetal. The second nonmetal is going to be changed. So instead of like changing to "ide", we are actually going to change to "ic" instead. For example, fluoride would be fluoric, chloride would be chloric, iodide would be iodic, right? So that would be an example here. So for example, these are the anions that we have, right? The name of the anion is ending with "ide", so similar to what we did earlier in the ionic compound. Corresponding acid, okay, so pretty much we already know that acid would give off proton, which is hydrogen ion, which is this species. So pretty much the corresponding acid would be the combination between these hydrogen ion with all of this, right? So you're gonna do it similar to how you did it with the ionic compound. Okay, so pretty much this is 1 plus, this is 1 minus, so therefore the corresponding acid would be just 1 to 1, right? It would be HF, right? So this is also 1 to 1, this is also 1 to 1, this is also 1 to 1. Therefore the corresponding acid of the fluoride would be HF. Okay, so this would be the acid that derived from fluoride. The name for this would be hydro, right? We're going to specify hydro first, followed by the second element, but we're going to change to "ic" instead of "I". So this one, instead of fluoride, it would be fluoric. Okay, and then ending with the word acid. Okay, so the ending acid will specify that this is an acid. So you will need to also include as the aqueous as well. Okay, so you need to include that. Okay, second one, same thing, right? So the corresponding acid for second one would be HCl, and the name for this would be hydrochloric acid. Okay, so it's have to ending with "ic" and then followed by acid. HBr would be next, because if you add hydrogen plus to Br minus, that's what you're going to get, right? HBr. So the name would be hydrobromic acid. And iodide would be HI, right? And then the name would be hydroiodic acid. Okay, so again, all of these must contain the aqueous. Okay, so if you can actually write that down for me. Okay, so it would be part of that. Okay, so it's going to contain, it's indicated this is in water, right? In the solution that contain water. Next, we are going to take a look at the naming for the oxy acid, or the acid that contain oxygen as well. Okay, so pretty much the name of these would exclude the word hydro. Okay, so before, if you have binary acid, you have to indicate the word hydro. For the oxy acid that contain more than 2 elements, right? So you have H, X, and O, you are going to exclude the word hydro. You are going to use the name of these polyatomic ions, right? And it depends on what their name are, because if their name are 8, ending with 8, then you have to change to ic and then followed by acid. If their name are ending with ite, then you're going to change their name to us and then ending with acid as well. Okay, so what do I mean by that? Okay, so let's take a look at all of these polyatomic ions. Okay, so these are the polyatomic ions, which is going to be this part right here, right? So it's going to be the XO part. Okay, so this XO part is indicate the polyatomic ions. Okay, so as we already look at the polyatomic ions, some of them are ending with 8, some of them are ending with ite, and the difference between those is just the number of oxygen, right? 8 has more oxygen than ite. Okay, so pretty much what you are going to so my expectation is you will need to be able to write the corresponding acid from the anion that is given, and also be able to tell me the name as well. What do I mean by that? Again, so we are going to be based off the proton or the hydrogen ions, right? So hydrogen ion is H plus. Okay, so we are going to combine this H plus, okay, so with the rest of this by balancing its charge. Okay, so in this case, if you're looking at H plus, okay, the second one NO3, and there is the superscript -1 right here. Okay, so it's look a little bit lower, but it's actually superscript there. So this one is called nitrate. Nitrate has 1 negative. Hydrogen ion has 1 positive. Therefore, the corresponding acid would be HNO3. Remember, you have to write the hydrogen first. How to recognize acid is have to be hydrogen written first, right? So hydrogen written first, followed by the polyatomic ion NH3, and it's 1 to 1 in this case. The name of this acid would be, okay, so again, these contain more than 2 elements. Therefore, we don't need to use the word hydro. We are going to name this acid based off the name of the polyatomic ions. This is ending with 8. We are going to change this 8 to ic and then followed by acid. So instead of nitrate, you're going to change to nitric and then ending with acid. So it would be nitric acid. Okay, same thing for nitrite. Okay, so the corresponding acid of this would be HNO2. The name of nitrite is need to be changed to us, so therefore it's going to be nitrous and then followed by acid. Okay, so same thing for the next one. Okay, so however this one we have sulfate with the 2 negative. Therefore 2 negative, in order to balance with the H plus, you will need 2 of this, right? So therefore in this case you are going to need 2 of the hydrogen, so that's why we do H subscript 2 and then followed by the sulfate ion. The name of this, again, because it's sulfate, you are going to change to, it's not sulfic, but it's going to be sulfuric. Okay, so this is something you will need to know. So it's come from like sulfur and it's you ending with ic. Okay, so it would be sulfuric acid. Okay, and for sulfide would be H2SO3 and the name would be sulfurous acid. Okay, so if you continue doing this, you will see that those are the number of ions, right? So this one is -3, -2, -1, -1, -1, -1, -1, -1. But those are the subscript, right? So these are the subscript. Okay, so these are the subscript that I highlight in green. Okay, so that means in this case, for phosphate, you will need 3 hydrogen ions. So therefore, you're going to have H subscript 3, PO4. And the name for phosphate, you are going to go back to phosphorus and changing us to ick, right? So phosphate would be phosphorus. Oh, sorry, it would be phosphoric acid. Okay, so ending with ick. Carbonate would be H2CO3, and it would be carbonic acid, right? So that's the acid in like carbonate water. Now, what about bicarbonate? Okay, so if you think about this, bicarbonates contain HCO3 and 1 minus. So therefore, if you want to write this, you do H, and polyatomic ion is HCO3, right? So in this case, because these two are identical, okay, you can actually combine this. So therefore, it's going to be H2CO3, which is going to be the same, right? So these two, when they are making up corresponding acid, is actually making the same acid. Okay. Acetate, if you write the hydrogen, there are two ways to write acetate chemical formula. One is to write hydrogen written first, like what we just learned, and followed by the anion CH3CO2. This is also correct. This is also correct as well. The first way that I show here, this is the form that you are going to see later on when we talk about organic compound, because the way that it's written for this form is telling you about the location that is actually connected to, like what atom is connected to. This form right here, it's just this what do you call, like the simplest form that most of the beginner, like the beginning learner, right, would learn, because they are able to recognize the hydrogen written first. So these two forms are identical to me. Okay, so you can choose one way or the other. So what I would do if I were you, I would just stick with this green highlight one, because you will need to recognize that hydrogen written first. It might be easier for you. But later on, you will see that this form, it will be acceptable as well, because this one will tell you about the connectivity of each element within the compound. Okay, so this name acetate, the name of acid from acetate would be acetic acid. Okay, so which is the acid in vinegar. Right. So if you continue doing this, here are the rest of it, right? So you're going to have perchloric acid, you will have chloric acid, you will have chlorous acid, and hypochlorous acid. Okay, so that's how you recognize this. Again, to finish this correctly, all of these need to contain aqueous. Okay, so make sure that all of these acids have to be in aqueous solution, which is the solution that contains water. Okay, so let's add all the aqueous for me, please. Okay, and I'm going to rewrite another form of this. So another correct answer for this one is HCH3CO2. Okay, so that's another form also. So this is acceptable as well. Okay. All right, so the one that is going to be used the most for the rest of this chemistry sequence would be the one that I highlight in red. Okay, so you're going to see this most often. Okay. All right, so let's take a look at number 2 as an example. Okay, so that way we can practice this. If I ask you to write out the chemical formula or name for specific compound, right, you will need to be able to do that as well. So this one said carbonic acid. Of course, because we know that it's acid, so you will need to include AQ. Okay, so we know that it have to be in aqueous, and because it's an acid, so hydrogen must be written first. Okay, so we have to include hydrogen. So hydrogen is going to come with something, right, and then ending with aqueous. So it's come with what? Okay, so it's come with this, right, carbonic. Okay, so because it's ending with ic, which means it's going to come from the polyatomic ions ending with 8. Right, so this is going to come from something that ending with 8, because we changed 8 to ic, right? So that's how I know. And the name that ending with 8 are those that are polyatomic ion. If you look up the list of polyatomic ions on page 84, you will see that carbonic is going to be similar to the word carbonate, right? So this one is similar to the word carbonate. Therefore, in this case, you will need to use the chemical formula of carbonate, which is CO3 2 minus. we're gonna use these to balance off the proton. Okay, so remember, each proton is 1 positive. This one is 2 negative, therefore we need 2 protons. So you need to use 2 subscript, right, as the number of hydrogen, and then followed by the carbonate, which is going to be CO3. Okay, so this would be the chemical formula of carbonic acid. All right, second one, this one right here doesn't contain any oxygen. This is part of the binary acid, right? We know it's acid because of aqueous. So I'm just gonna go ahead because it doesn't contain any oxygen. So this is the binary acid. So therefore the name would start with the word hydro. Okay, so you're gonna start this with the word hydro. Hydro something, right? And then because of an acid, we are going to ending our name with the word acid. Okay, so it would be something acid. Let me find the color. Okay, so we're gonna ending this with acid. All right, so what is this one then? Okay, so that means we're gonna have to find the second element. Second element, we are always gonna ending with ic, right? So it's going to be sulfuric in this case. So that means it's going to be hydrosulfuric acid. Okay, let's take a look at C. C is not a binary acid anymore. The reason for that is because I recognize hydrogen written first, it have to be acid, right, with the aqueous. And also it's contain oxygen, so it's not binary. This is coming from polyatomic ions, and this is the part of the polyatomic ions. Therefore, we would not have to include the word hydro. Okay, so we are going to use this name right here, which is SO4. Okay, so it's SO4 2 minus. The name of SO4 2 minus is sulfate. So because ending with ate, we are going to have the name that ending with ic. So therefore, in this case, it would be sulfuric. And then followed by the word acid, right? Because hydrogen is written first. Note that the reason why I have side-by-side name right here between B and C is for your comparison. One that doesn't have oxygen need to contain the word hydro. One with oxygen, you are going to exclude the word hydro. Okay, so that's the difference between these two. Okay, because they are different molecules. Okay, the next one, HBr. Okay, so again, HBr, this one doesn't contain oxygen, right? So it's contain only 2 elements. So this is binary acid. Therefore, you will need to indicate that it's going to be the word hydro. Listen first, right? And this is an acid because you have hydrogen written first with the aqueous. So that means it's going to somehow ending with the word acid. Okay, so what come between then is going to be the name of the second element, right? So bromide, we are going to change to bromic. So this would be hydrobromic acid. All right, the next one is 2E, periodic acid. Okay, so again, this name right here doesn't start with the word hydro. Therefore, we know that this one have to be the polyatomic ion. Okay, so this one have to come from polyatomic ion, which are the ions that contain oxygen, right? So you can look at these on page 84 to see the list of it. Okay, so polyatomic ions that is close enough for the periodic, it would be periodate, right? So this one is going to come from the word periodate. How do I know? Well, because we know that if it's ending with ate, we change to ic, right? So that's how I know. So if you look up the chemical formula of periodate, you will see that it's going to be IO4 minus. Okay, therefore the chemical formula of this, because the iodate is 1 minus, therefore you are going to use only 1 hydrogen, right? Because hydrogen ion is positive 1, this is negative 1, so it's going to be 1 to 1, so it's going to be HiO4. Oops, it would be HiO4, right? And because it's an acid, so we're gonna ending with AQ as well. It's going to be in the aqueous solution. Okay, let's take a look at the 2F. Okay, so hypochlorous acid. Okay, hypochlorous acid would be because that it doesn't contain hydro. Again, this name right here would come from polyatomic ions on page 84, right? The one that closest to this polyatomic ion's name would be hypochlorite. And as we know, right, whenever you see ending with "ite," you are changing to "us." So that's why you see the name in the acid change to "us," right? Because you're changing from "ite" to "us." So what is the chemical formula of hypochlorous then? It's going to be ClO minus. So this would be hypochlorous. So therefore, the chemical formula of this would be, because it's an acid, hydrogen must be written first, right? Then followed by the anion, which is the hypochlorite ion here with one negative charge. So therefore, you're gonna have 1-to-1 ratio here. So which is ClO, and then ending with aqueous. Okay. Last one. Okay. So we have hydrogen written first. So that, and also we see the aqueous as well. So this is an acid for sure. Okay. So I'm going to read this as an acid. Okay, what should be the name of this then? Well, of course, this is not binary acid, so that means we don't need to specify the word hydro. We are going to look up what this C2H3O2 is, right? So if you look it up, this is the acetate. Okay, so this is acetate. Because it's an acetate, right? We're gonna ending it with ic. So therefore, the name of this acid would be acetic acid. So here's the summary of what I just mentioned earlier. It's just cleaner for this slide. For more practice, please start working on the DIY problem, page 92. The answer key for this is already posted on Moodle under chapter 5. You will need to do this because these are the list of the substances that are some of them are molecular compounds, some of them are ionic compounds. They have their name system differently, right? And how you determine their chemical formula is also different as well. So by practicing this, you are going to get a hang of it, and you are going to do well on the exam, because you will need to do this on your own. Do not look up the answer key first. Do it yourself first before you check your answer against the key. If you get it wrong, that's when you address your mistake, right? Either by me, or you can get the tutor to help you with that. Okay, so pretty much the type of compound will tell you about how can you actually going to name this, right? Because the molecular compound and ionic compound have different system. Okay, so, and then you can give me either the name or chemical formula. It depends on what is given here. If it's already given chemical formula, you need to provide me the name. If it's giving you the name, then you need to provide me with the chemical formula. Okay, so let's practice on this. The exam will be similar to this, by the way. And pretty much overview of this video would be, you learn about the naming of binary molecular compound. You also look at the molecular compound that are acid as well, which means that you're going to see hydrogen written first that come with aqueous. Okay, and then there are two types of acid. One is containing only 2 elements, which is what we call binary acids, right? The other one is going to be the one that contains more than 2 elements and including oxygen as well. So this is what we call oxyacid. The name system for this can be differentiated by the word hydro, right? So the binary acid would include the word hydro. The oxyacid would not include hydro, right? So for example, we talked about that already when you have H2S, right? So this would be hydrosulfuric acid, right? But if you have H2SO4, this would be sulfuric acid, right? If you have H2SO3, this would be sulfurous acid, right? Because it's come from sulfite, you change I to us, and then if it's come from sulfate, right, you change A to ic, right? So it would be sulfuric. Okay, so that means the name of this would be different depending on the number of elements within the compound. Okay, so pretty much after this video, please start working on your homeworks